Hi, this lesson is about solving systems of linear equations using the addition method or the elimination method. So in 9.1, we talked about the substitution method. So this lesson is dedicated to the second one. So I usually call it addition method, but elimination method means the same thing. Okay, so here's an example. We want to solve x plus y equals 3 and x minus y equals negative 9. And again, just to keep us organized, I'm calling the first one equation 1 and the second one equation 2. So the technique behind the addition method is that you are adding the two equations in order to eliminate one of the variables, hence the names. So this one, we can get straight to that. We're going to add equation 1 and 2. So I've written them here vertically, so you can see that I'm going to add vertically. So when I combine like terms, x plus x gives me 2x. The y's cancel because they're opposite signs, and the right side becomes negative 6. So when you solve for x, you get x is negative 3. But just like with the substitution method, you need a point, not just a single value. So I need an x and a y. So I need to substitute x equal to negative 3 into one of the equations above. And it doesn't matter which equation you choose. I chose equation 1. So I'm going to let x equal negative 3 in equation 1. And when you do, you get negative 3 plus y equals 3. Add 3 to both sides, and you get that y is equal to 6. So our solution is negative 3, 6. And again, this is what we would consider to be an independent system. And the solution represents the point of intersection of the two equations. Okay, let's do another example. Here I have x plus 5y equals 6 and 2x plus 7y equals 7. All right, so unlike the last example, let me just bring that back. In my last example, my y's just kind of naturally would cancel because in the first equation, it's plus y, and in the second equation, it's minus y. So in this second example, I don't have that. If I added these two equations as they are, nothing would cancel. So that means I have to manipulate one of them. So you have to make a decision as to which variable you want to eliminate. So I'm going to eliminate the x's this time. In order for me to eliminate the x's, I need for the top equation, or the number 1 equation, to have a negative 2x in the first position. And in order for that to happen, I have to multiply equation 1 by negative 2. Okay, when I multiply equation 1 by negative 2, that means I have to multiply negative 2 by every single term, not just the x. So that's what you see immediately to the right here. Equation 1 multiplied by negative 2 is negative 2x minus 10y equals negative 12. Then I'm going to take that new equation 1 and add it. We want to add it to equation 2. Here's equation 2. All I did was copy it down. Then you add equation 1 above, which got changed, and equation 2 below, and that's what you see below. The two x's will cancel because one is positive and one is negative. Negative 10y plus 7y, well, that becomes negative 3y. Negative 12 plus 3 becomes negative 9. Divide by negative 3, and you get that y is 3. Okay, but again, you need both an x and a y value in order to solve this equation or this system. So you're going to take y equal to 3, and you're going to substitute it into one of the equations. I'm choosing to substitute it into equation 1. So I get x plus 5 times 3 equals 6. So that's x plus 15 equals 6. Subtract 15 from both sides, and you get x equals negative 9. So our solution is negative 9, 3, and this is again another independent system. So whenever you get x and a y value, a single x and a single y value, that's considered to be an independent system. All right, so let's move on. This one is a little bit more challenging. We want to solve the system that you see right here. Again, I've called the first one equation 1 and the second one equation 2 just to make it easier to keep track of what I'm doing. Again, I cannot eliminate a variable in the condition that they're in. So if I were to add them as they are, 3x and 4x would become 7x, 7y and negative 3y would become 4y. So neither variable would get eliminated. Okay, so this time, in order for me to be able to add my two equations and eliminate one, I have to determine which variable I want to eliminate, and then figure out what I have to do to each equation in order for them to cancel. So I'm choosing to eliminate the y. We'll eliminate the y. Notice that the coefficients of y are 7 and 3. So I have to identify what the LCD of that is. The LCD of 7 and 3 is 21. So now equation 1 has to get multiplied by 3, and equation 2 has to get multiplied by 7 in order to get that LCD of 21, or LCM I should say, in that y coefficient. All right, so that's what you see here below. This is equation 1 multiplied by 3, so that becomes 9x plus 21y equals 66. And this is equation 2 multiplied by 7, so that's 28x minus 21y equals 119. So that's what I mean by getting that value there where you have 21y and negative 21y for your y coefficients, because when you add equation 1 and 2, they will cancel. So 9x plus 28y is 37x. The y's cancel. 66 plus 119 is 185. Then divide by 37 and you get x is equal to 5. So again, I need to find now my y value. So you're going to let x equal 5 in one of the equations above. So I chose equation 1. Let x equal 5 in equation 1. So 3 times 5 plus 7y equals 22. 3 times 5 is 15, plus 7y equals 22. Subtract 15 from both sides. You get 7y equals 7, and therefore y equals 1. So your solution is the coordinate 5, 1. Remember, that's your point of intersection for the two equations, and this is another example of an independent system. Okay, let's move on to this one here in purple. So I want to solve x minus 3y equals negative 5. That's my equation 1. And I want my second equation to be negative 3x plus 9y equals 12. All right, so again, we have to strategize here and determine which variable do we want to eliminate. So I'm going to eliminate x, and in order to eliminate x, I have to multiply equation 1 by 3. So that's what you see here. This is my new equation 1. You get 3x minus 9y equals negative 15. And equation 2 was not changed at all, so I'm just copying it down right here. So now I'm ready to combine like terms. So when I do that, notice that everything on the left side, all of your variables cancel out. And on the right side, you have negative 3. So 0 is certainly not equal to negative 3. Remember, when you get a strange result like that, that means that you have no solution, and no solution means it is an inconsistent system, which means the lines are parallel. They'll never touch. Okay, so if you're working on your WebAssign, they will expect you to write the words no solution for something like this. Okay, let's move on. Here we want to solve this system. 2x minus y equals 1 is equation 1, 8x minus 4y equals 4. That's equation 2. So again, strategize by figuring out what you want to eliminate. Suppose you decide that you want to eliminate the y's. If I want to eliminate the y variables, I need for this one here to be a positive 4y. So in order for that to happen, I multiply equation 1 by negative 4. All right, so that's the work that you see below. Equation 1 multiplied by negative 4 is what you see here. So you get negative 8x plus 4y equals negative 4. And equation 2 is just copied down. So I have 8x minus 4y equals 4. So when you add these, everything cancels, the left side and the right side, so you get 0 equals 0. That's true. Unlike the previous example, 0 does equal 0. And when you get a result like that, that means you have an infinite number of solutions. That's what we call a dependent system. Okay, so how do you express the solution to a dependent system? The first coordinate is always x, and the second coordinate is one of the two equations solved for y. It doesn't matter which one you choose. I chose equation 1 and solved it for y. If you chose equation 2, you should get the same exact answer. So when you take equation 1 and solve for y, you subtract 2x from both sides, multiply both sides by negative 1, so you get y equals 2x minus 1, and that's exactly what you put in here. 2x minus 1 is the y value. So your solution is x, 2x minus 1. Okay, so now you're ready to try the homework for this section. Good luck.